Section 3.4 is going to seem similar to Section 3.3, but we're going to go backwards. Instead of being told that the lines are parallel and making statements and things that we know about the given angles, we're going to prove that the lines we have are parallel. So going back to 3.3, the first thing we wrote down in Section 3.3 was postulate 15, that if two parallel lines are cut by a transversal, then the corresponding angles are congruent. What we were working on in this section is the converse of that. So the first thing we need for this section is the converse, which is postulate number 16, that if two lines are cut by a transversal, so that corresponding angles are congruent. So if I have two lines, and there's a transversal that crosses them, and the corresponding angles are congruent, so a single arc and a single arc, then the only way that's possible is when these lines are parallel. Therefore, having those corresponding angles congruent proves that the lines are parallel. My reason for this would be corresponding angles converse, because you were using the converse. We're going backwards and making a statement that says, yes, the lines are parallel. Theorem 3.8 says if alternate interior angles are congruent, so if I have these two lines and there's a transversal that crosses them such that the alternate interior angles are congruent, then I can say yes, this line L and this line M are parallel. My reason for this would be alternate interior angles converse. And it's very important that we use the word converse, because instead of being given that the lines are parallel and making a statement about the angles, we're given that the angles are congruent, and we're making the statement that the lines are parallel. So we're doing the flip-flop. We're doing the converse of what we did in 3.3. So alternate interior angles converse. Theorem 3.10 says if the alternate exterior angles are congruent, so if I have two lines such that the transversal crosses them and the alternate exterior angles are congruent, then the only way that happens is that the lines are parallel. So I can say L is parallel to M, and my reason is just what kind of angles they are and the word converse. So we're going to do alternate exterior angles converse. Theorem 3.9 also gives us two lines and a transversal that crosses them. If the consecutive interior or the same side interior angles, so this one and this one, those are consecutive interior or same side interior, if those are supplementary, if together these add up to equal 180 degrees, then the lines are parallel. My reason would be consecutive interior converse, because now we're going backwards. We're given some information and we're making a statement that the lines are parallel. I could also put same side interior. Okay, so let's look at some examples. We're not sure if the lines are parallel or not. What we're going to look for is we're going to look for where the angles are. And we're going to see, first thing, is it a special pair of angles? Are they alternate interior, alternate exterior, corresponding, or consecutive interior? And if so, do they do what they should? Are my alternate interior, alternate exterior, and corresponding equivalent? Do the same side or consecutive interiors add up to 180? Are they supplementary? If so, that will cause two lines to be parallel. When you're looking at these angles, we're only going to use three of the lines that are given if it makes lines parallel. We'll have a pair of lines that are parallel and one line that's a transversal. So there should be a line that we can ignore, that we don't have to use in the picture. For example, we know that angle 1 is congruent to angle 16. Angle 1 touches lines A and C. Angle 16 touches lines B and C. At no point do we need to use D, and that's going to be a helpful hint. I should be able to cross out a line. If I can't cross out a line, then they're not making lines parallel. If I can cross out two lines, then they're not making lines parallel. So I don't need line D for example 1. 1 and 16 are a special pair of angles. Those are corresponding. Since angle 1 and angle 16 are congruent angles that are a corresponding pair of angles, it does make parallel lines. Therefore, C is by transversal, and this causes A to be parallel to B. My reason would be corresponding angles converse. We're going backwards and making the statement that the lines are parallel, so we use the word converse. Number 2, which lines are parallel if angle 13 is congruent to angle 11? So we have angle 13 and angle 11. The first thing I notice is I can cross out a line. Angle 13 is touching line B and line C. Angle 11 is touching line B and line D. So we're not using line A. I'm going to ignore that line. That's a good hint that I'm probably going to have a pair of lines parallel. 13 and 11 are alternate interior angles. They're on different sides of B, which would be my transversal, and they're in between lines C and D. Alternate interior angles are congruent if the lines are parallel. Therefore, we could say that C is parallel to D, and if I needed a reason, it's alternate interior angles converse. If you're making the statement that the lines are parallel, we need to use the word converse. Example 3. Which lines are parallel if angle 5 is congruent to angle 10? Angle 5 and angle 10. I notice angle 5 is next to lines A and D. Angle 10 is next to lines B and D. So line C is not needed to work this problem. Looking at these, angles 5 and 10 are on opposite sides of D, so that would be like my transversal, or it would be my transversal. 5 and 10 are alternate exterior angles. If alternate exterior angles are congruent, it does make the lines parallel. Therefore, A is parallel to B, and my reason would be alternate exterior angles converse. Number 4, which lines are parallel if angle 16 is congruent to angle 14? So here's angle 16 and angle 14. Angle 16 is touching lines B and C. Angle 14 is also touching lines B and C. I'm not using A and I'm not using D. Automatically, this is not going to make the lines parallel because I must have 3 lines to use, a pair that are parallel and a transversal. What's happening with 16 and 14 is they're vertical. Vertical angles are always congruent. That does not cause lines to be parallel, so our answer is none. Example 5. Angle 6 is congruent to angle 12. Angle 6 and angle 12. I notice angle 6 is touching lines A and D. Those are the ones it's next to. Angle 12 is touching lines B and D. So I'm not using line C. Well, D would work as my transversal, and 6 and 12 are on the same side and right in a row in between lines A and lines B. So those are same side or consecutive interior. In order for lines A and B to be parallel, the same side or consecutive interior need to be supplementary. I'm not sure if these add up to 180. The only thing I know for sure is that 6 and 12 are congruent. They could each be 60 degrees. Since I can't be definitely sure without making an assumption that those are supplementary, this is not going to prove that lines are parallel. Example 6. Which lines are parallel if angle 16 is congruent to angle 10? So angle 16 and angle 10, and this is the same picture used over and over. I notice that 16 is next to lines B and C, 10 is next to lines B and D, so I'm not using line A. Well, looking at angle 16 and angle 10, B is my transversal, and they're on opposite sides, so they're alternate, and they're outside of my 2 lines. These are alternate exterior angles. That is one of our special pairs. In order for alternate exterior angles to be congruent, that does tell me that lines are parallel. So I could say that line C is parallel to line D. And remember, if I need a reason, it's what kind they are, and it's the converse. So this is alternate exterior angles converse. Example 7, angle 3 is congruent to angle 10. Angle 3 is touching lines C and A. Those are the ones it's next to. Angle 10 is next to lines B and D. I cannot cross out a line. These are not a special pair. They almost appear to be corresponding, but corresponding angles have to be next to the same transversal. Corresponding to angle 3 would be 7 or 14. Corresponding to 10 would be 8, or I'm sorry, 7 or 14. So they're corresponding to the same angles, but not to each other. Therefore, none of the lines can be proven parallel with this information. Example 8, which lines are parallel if angle 3 is congruent to angle 15? I notice that angle 3 is next to lines A and C, angle 15 is next to lines C and B. This is not using line D. Looking at 3 and 15, they're on different sides of the transversal. Line C is my transversal, but they're not both interior. 3 and 16 would be alternate interior. And they're not both exterior. 15 and 4 would be alternate exterior. So this isn't a special pair. It's not corresponding. It's not alternate interior. It's not alternate exterior. It's not same side interior. Therefore, because it's not a special pair of angles, none of these can be proven congruent. Example 9. Which lines are parallel if angle 3 plus angle 6 equals 180? So this time I don't know if anyone's congruent, but I know that 3 and 6 together add up to 180. Angle 3 is next to lines C and A. Angle 6 is next to lines D and A. So I'm not using B. We're going to pretend that line's not there. And you might just take your hand and cover it up on the screen. Looking at 3 and 6, they're both interior, but they're on the same side of our transversal A. Therefore, these are same side interior or consecutive interior angles. Those are a special pair that in order for lines to be parallel, they must add up to equal 180. And that's what we were given. So line C is parallel to line D. And for a reason, I could put consecutive interior or same side interior angles converse. If you're stating that the lines are parallel, you must have the word converse. For classwork, we're going to be working on page 153 to 156, numbers 10 through 26, number 38, and number 44 to 48.